How are you, class? I hope you are doing well. Today we want to look at lesson number 5, which is externally intersecting chords. Remember, in our last lesson we covered internally intersecting chords. I hope you are able to do some examples or exercises on the same. So today I will go straight to the externally intersecting chords. So as you can see, I've drawn two chords. I can call this chord A and B. Then I call this C. As you can see, the chords are meeting outside the circle, and that's why we are saying they are externally intersecting. They are not meeting within, but they are meeting outside the circle. So now, from our previous topic, from our previous lesson, we agreed that angles subtended by the same chord are equal. Now, I have introduced two lines, AN and CM. This AN has formed a triangle, ANB, and also we have come up with another triangle, CMB. Now, the angle AMC, if I call it theta, will be equivalent to the angle ANC. Why? Because AC is the same chord that has subtended those angles at the circumference of this circle. Now, equally, I can talk of angle NAM and I call it beta, for example. It will be the same as this other angle beta down there because they have been subtended by the same chord NM. Now, I want to extract the two triangles that I've introduced so that we can see how their similarity and how they will help us to calculate the distances AB or MB, AB or NB. So the first triangle I will extract is triangle CMB, where C is beta, and I also have this angle here. Because this is a straight line, this is 180 minus theta. So this angle here is 180 minus theta. Then this is another angle, which is MBC is a common angle. So let me call this angle alpha. I want to draw this other triangle, and I'll flip it so that you can be able to correspond with the other. So my angle, this is going to be A, which is beta degrees. This angle here is 180. As you can see here, this is 180 minus theta again. So this is 180 minus theta. Then the remaining angle, which is common, this angle has not changed for the two triangles, so we call it a common angle. It is going to be alpha like this. Now, we are interested in getting these distances there. So AB is this corresponding with A. This is N. This is N. B. Remember, this is common. So this is this is corresponding, this CB is corresponding with AB. Then we are also interested in MB. MB, which is corresponding with NB. So I can say that from similarity concept, we can say that MB over NB will be equal to CB over AB. So if we cross multiply, we are going to get that MB times AB equals to NB times CB. So if we are given the distances of the other lengths, and maybe we miss one, we can be able to derive that one from this formula. So let's have an example. Calculate the distance MB in the figure below. AB and M, and AN is 5, NB is 4, CM is 9. So we are required to get MB, which we can call maybe X. So the formula here is 4 times 4 plus 5 is 20. 4 plus 5, sorry, is 9, equals to X into X plus 9. So if we open the brackets, here we can multiply. Here we have 36 equals to X squared plus 9X. So if we can rearrange this, we get X squared plus 9X minus 36 equals to 0. You can get the factors and then solve that. So this is X squared plus 12X minus 3X minus 36 equals to 0. So that is X into X plus 12 into 3 into X plus 12. So as you can see, we can have X plus 12 equals to X minus 3. Therefore, X is equals to negative 12 or X is equals to 3. So because we don't have negative distance, we ignore the negative, the negative value of X, and take the value of X as 3. So the answer here, X is 3 units. I hope you have enjoyed our lesson. I want to go to KMF, choose some of the questions and do them. Do more practice from KMF and KLB. And I hope you have enjoyed our lesson today. Have a nice time.